Okay, skill 20, analyzing rotated conics. First I did pick three positive integers, so a squared, b squared equals c squared. Bam, did that. Then we picked d and e. Well, oh, sorry, look at the wrong thing. Then chose two additional distinct integers d and e so that each is greater than 3. Then let tan of theta equal b over a. And one of the foci in the center is d0. One of the vertices is d plus e0. So what I got from that is I found the center, the vertexes to c's, there we go, and the foci. And so this was the tan that we got. We got theta equals 22.61936. And then these are the different characteristics about the conic. And then, so first we want to turn the equation into polar, and so that is what I did here. I plugged in the values into this equation to get to here, and we had to find e, which was c over a, so that's 5 over 4, and then from there I went across and just kind of plugged things in, and then did the multiplication and addition, and got 9 over 4 up here, and that's over 1 minus 5 over 4 cosine theta, so that's what r equals. Oh, sorry, printer. Alright, this is the polar equation of the rotated conic, but in order to convert it back into rectangular form, you have to multiply both sides by this, so that it's just 9 over 4, and so we get that to here. And once we're there, we can use the rule cosine A minus B equals cosine A times cosine B plus sine A times sine B, and then we use that to expand this to here. From there, we can use the triangle from earlier to find the triangle made with the different points that we had to find cosine and sine values for the inverse tangent of 5 over 12. And to do that, what we basically get from that is that the cosine of tan inverse 5 over 12 is equal to 12 over 13. And the sine of tan inverse 5 over 12 is 5 over 13. So we moved those and we plugged those back into here, and then multiplied everything on the left side out, gets us to here, and then from here we use the rules up here that we know about. So we turn r into here, and we use these rules and change the equation and substitute out r and theta for x's and y's. So we'll get to here, then moved everything over to the right so we can isolate this. From there we squared everything, and after doing all the math here, you get to here, we move all, we move everything so that this is negative 81 over 16 is the only thing on its side of the equation. And from there, we divide everything, all the coefficients by negative 81 over 16, so that it equals 1. So it's the equation for the conic. And we end up getting this equation right here, and that is the final rectangular form of the conic.